In today's video, we're going to look at your assignment from Monday. You were asked to add and subtract numbers in scientific notation. All the problems on the left are addition problems, and that's what I meant by find the sum. Sum means the answer to an addition problem. And all the problems on the right are subtraction problems, and that's what I meant by difference. Difference means the answer to a subtraction problem. And then you also had to make sure your answer in the end is in scientific notation. I'm going to do a couple from the left side and a couple from the right side. Let's begin with number one. Before we do any math, let's go and read the sentence at the bottom because this sentence is key to this concept. When you add or subtract scientific notation, your exponents need to be the same. So before you do any math, check to see, are my exponents the same? In this case, yes, they are. They're both 10 to the fourth power. Once you know your exponents are the same, you're allowed to begin your steps. And step one says to use a distributive property. What we're going to do is we're going to pull out what they have in common. In this case, they have what is underlined in common. They both have times 10 to the fourth in common. So I'm going to take that outside of my parentheses. The stuff that's going to remain inside my parentheses is the things I didn't underline. In this case, it's 4.4, a plus sign, and 3.5. Now the stuff in the parentheses is a simple addition problem. 4.4 plus 3.5, that gives me 7.9. And then before you box your answer, you want to check, is your answer inside the notation? In this case, yes, the number is between 1 and 10. 7.9 lies between 1 and 10, so I can go and box this answer and we're all done. Let's look at a little bit more of a challenging problem. Let's look at number 6. Before I begin, I'm going to check, are my exponents the same? In this case, sadly, no, they're not. I have 10 to the negative 8 and 10 to the negative 9. So I can't do what I did in the last problem yet. I have to make them the same. So I need to make the negative 8 and the negative 9 the same exact number. What I recommend you do is you always change the smaller exponent. So who's smaller, negative 8 or negative 9? The answer is negative 9 is smaller than negative 8. So that means I need to increase the negative 9, and to make a negative 9 into a negative 8, I just have to add 1. But if I add 1 on this side, it's like a teeter-totter or a seesaw. If I increase this side by 1, I need to decrease the other side by 1. And when I say I'm going to decrease this by 1, what I mean is I'm going to move the decimal place 1 place to the left. I'm going to make it 1 place smaller. So this is now going to look like the left side doesn't change. 2.5 times 10 to the negative 8, I just bring it down. The subtraction sign I bring down. The 2 is no longer going to be 2. I moved it 1 place to the left. It's now 0.2. The 10 to the negative 9 is now increased by 1. It's now a 10 to the negative 8. Now that the exponents match, we're allowed to use a distributive property. The distributive property says take out what they have in common. That's the 10 to the negative 8. Everything else remains on the inside. And this becomes a simple subtraction problem. It was 2.5 minus 0.2. And that is going to give me 2.3. And once again, before you box your answer, check, is it in scientific notation? Yes, 2.3 is between 1 and 10. So we can box an answer and we're all done. Now let's look at number 8. Are my exponents the same? Sadly, no. I have a 5, I have a 3, so I need to make them the same. Once again, I recommend you change the smaller exponent. 3 is obviously smaller than 5, so I need to increase the 3 by 2 places. 3 plus 2 will give me 5. So since I increased this side by 2, I need to decrease this side by 2. In other words, I need to move that decimal place 2 places to the left. So my problem will now look like 1.45 times 10 to the 5th minus, it's no longer 3.3, it's now 0.033. This is no longer 10 to the 3rd, it is now 10 to the 5th. Now that the exponents match, I'm allowed to use a distributive property, pull out what they have in common, leave what they don't have in common inside the parentheses. This is a simple subtraction problem. 1.45 take away 0.033 is 1.417. And the times 10 to the 5th you just bring down. And once again, yes, my answer is in scientific notation, so I can box my answer. And finally, number 9. This one's a little strange. You have one number in scientific notation and the other number is just in standard form. So you need to make this other one written in scientific notation. If there's no power of 10, that means the power of 10 is simply 0 because anything with a 0 power is 1. So if there's no power of 10, that means our power of 10 is actually 0. Now we can ask ourselves the question, are our powers of 10 the same? And in this case, no. This is a 3, this is a 0, so I need to make them the same. Once again, I'm going to change the smaller exponent. 0 is smaller than 3, so I need to make the 0 into a 3. So I'm going to increase this side by 3. But since I increased this side by 3, I need to make the other side decrease by 3. In other words, I need to move that decimal place 3 places to the left. The problem will now look like 3.8 times 10 to the third plus 0.00274 times 10 to the third. I now have the exponents the same. I can use the distributive property, pull out what they have in common. This is a simple addition problem. 3.8 plus 0.00274 gives me 3.80274 times 10 to the third. These parentheses at the end are optional. You can remove them or keep them. It's up to you. Check, is my answer in sign of notation? In fact, yes, it is. We can box our answer and we're all done. Since you changed the smaller exponent, your answer at the end will always be in sign of notation. If you do it the other way, if you change the bigger exponent, you might have to worry about the ending and might have to change it. So that's why I recommend you change the smaller exponent. You're never going to have to worry about whether or not it's in sign of notation. It always will be.